Dear students, today we are going to do some problems. How to calculate the number of particles and how to derive the formula from the number of particles. Okay. So, before that, some points I'll give you. Types of lattice. Types of lattice. Points. Contribution of particle to one unit cell. Okay, contribution of particle to one unit cell. So this is just, if you know this one, you can able to do the problem. So if the lattice points are corners, each lattice point the corners donate, means contribute 1/8 portion. Next one, it is the face, it donates 1/2 half contribution. Body, center, then 1. Okay, the next one is if a center of edge center, then 1/4. Okay, what does that mean? Corners, already we discussed corners. How many corners are there? 8 corners. From each lattice point donate 1/8 of that particle to the particular unit cell. If face center, face, suppose for example here this is the face of the cube. So here one atom is there, it is shared by 2 unit cell. So half belong to this one, half belong to that one. So shared by 2, so 1/2. Next one, body center not shared by anything. So you will get, how you get? You get 1/2. Okay. So next one, edge center. Edge center, you see here edge center, how many edges are there in the unit cell? This is 1, 2, 3, 4. 4 edges, right? Then here also below also 4 edges. 1, 2, 3, 4. 4 edges, right? Then normally students they say total 8 edges are there. So top 4 edges, here 4 edges. 4 plus 4, 8. Then you see this one. What is this one? Height. So here 1, here 1, here 1, here 1. So 4 these edges. So 12 edges are there. So if there is a particle in the edges, here one edge, center of this edge, one particle is there, it is shared by 4 unit cell. Here 1, on the top 1 will come. So 2 over, that 1 more will come here. Then here also 1 more will come. So 4 unit cell. The particle or atoms at the center of the edges is shared by 4 different unit cell. So what we have to do, this we write one, if it is a edge center, it is 1/4. 4 people are sharing that one. Okay. So first let us see this problem. A solid has structure in which W atoms are located at the corners of the cube. So corners, W atoms at the corners, W atoms at the corners. So how many corners are there? 8 corners. So corners, what you will get? Contribution by each point 1/8 is equal to 1. Right? Next one, O atoms at the center of edges. O atoms at the center of the edges. So just now we have seen how many edges are there in unit cell? 12 edges. So 12. Contribution of each point by to the unit cell, that is edge center 1 by 4 is equal to 3. Next one, Na atoms at the center of the cube. Na atoms at the body center. Center of the cube means body center. Center of the cube is equal to 1. That means body center. Body center. So how many are there? W1, O3, Na1. So how will you write here each one? Here what is the formula given here? Na1, W1, O3. Normally we don't represent 1, so Na, W, O3. This is the formula of the compound. Okay, so if you know this one, it is very easy to calculate this one. Types of lattice point. If lattice points are at the corners, each point contribute 1/8 portion of that point to the unit cell. If it is in the face center, then 1/2. If it is a body center, whole 1. The next one, if it is a edge center, it is 1/4. Okay, thank you. We'll see the next problem. Hello students, now we are going to do another problem. Okay, so here if 3 elements P, Q are crystallized in a cubic unit cell with P atoms at the corners, Q atoms at the cubic center and R atoms at the center of each face of the cube, then write the formula of the compound. Okay, so first one, P atoms at the corners, so how many corners are there? 8 corners. For the contribution, 1/8 is equal to 1, right? That is P atom 1. Then Q atoms at the center means body center, so 1. Cubic center means body center. Then R atoms at the face, it's R atoms at the face. Okay, how many faces are there? 6 faces. So in the face, what is the contribution of each point to the particular unit cell? 1/2 is equal to 3. So how many P atoms? P1, Q1, R3 is equal to P, Q, R3. This is the formula of the compound. Okay, so this is at the corners, contribution 1/8. Body center not shared by any other unit cell. Face center, it is shared by 2. So 6 faces, 6 into 1/2 is equal to 3. So the formula is PQR3. Okay, thank you. Then we will see the next problem. Hello students, let us do this problem. Okay, a unit cell consists of a cube in which A atoms at the corners and B atoms at the face centers. 2 A atoms are missing from the 2 corners of the unit cell. What is the formula of the compound? Right? So first one, a unit cell consists of cube. So first one we can see here, this is unit cell. Normally if you see unit cell, how many corners? 8 corners. Normally it will be 8 corners, so 8 points will be there. Here what is happening here? 2 A atoms, this one A atoms, all A atoms at the corners. 2 are missing. That means you can remove these 2, any 2. Okay, suppose just for your understanding we are removed. Here it is in the problem, it is given 2 A atoms are missing. So how many atoms are there? Only 8 corners are there. 8 corners. If 8, 1 by 8, normally we get, if you will get 1. Here it is, this is for all. Normally we do like this one. Here now it is there only 6 corners only atoms are there. So A atoms present at 6 corners. 6 corners. Okay. So what you will get, which one? 6 into 1 by 8 is equal to, what you will get, what you can write here, if you get 6 by 8, 3 by 4 is equal to 3 by 4. So A, how many A atoms are there? 3 by 4. Next one, B atoms at the phase center. B atoms at the phase center. Phase center is equal to 6 phases 1 by 2. So what you will get? 3. So A atoms 3 by 4, B atoms 3. So we know atoms cannot be in fraction. So we are multiplying this one into 4, this also into 4. So what you will get? This cut off, this you will get A3, B12. A3, B12. You can simplify this one, 1, 3, 4, 3. So A1, B4, that is equal to AB4. This is the formula of the compound. Do you understand? Once again repeat, you see here, a unit cell consists of cube in which there are A atoms at the corners. First they are telling A atoms are at the corners, okay. So just we will think 8 corners, so 8 points will be there, 8 atoms. But what is written next one? 2 A atoms are missing. So from 8 corners, from 2 corners, 2 atoms are missing. So how many are there? Only 6 are there. A atoms present at 6 corners only. 6 corners only. So 6 into, from the corner atoms contribute 1 by 8 to the unit cell. So 1 by 8. So what you will get? 6 by 8. So here also 3 by 4. Okay. So A is 3 by 4. The B atoms are the phase center. That we know. The atoms which are the phase center, what is the contribution to the unit cell? 1 by 2. Okay. So here 6 into 1 by 2, 3. So A 3 by 4. B what will be there? 3. So we are multiplying by atoms, can never be in fraction. So what you are doing? Multiplying by 4. This also you will multiply by 4. Okay, so equal distribution. So 4 here only A3, B12. Still you can simplify this one. You are getting A1, B4. Okay, thank you children. Now today I think you understood the problems. Then practice at home. Okay, thank you.